Hello, class. All right, so we're going to talk about this first lab that we're going to do. And this one is just going to be on a computer, no actual experiments. And this is on formatting lab reports. And so here, we're going to talk about three main topics in this lab. One is equations, like how do you actually type an equation in a document? That's something I think we should just know how to do. Uh, in the past, you know, students would often type up a lab report, and when it came to an equation, just like leave a space and then write it out in pencil or pen afterwards. And but we're kind of at the point now; everything is online. You should be able to create a document like a file and post it online so other people can see it. So it's something that's worth knowing. So I made this lab specifically for that reason. So we can just do things like create these type of documents that include equations and also things like tables and image files. So we can put them all in there. And not everybody knows how to do that. And so that's what this lab is for. So, like, after doing this lab, you shouldn't have any trouble doing, in the additional, like, future lab reports, you should know how to do all of these things. And, some of you may know this already. This might be an easy assignment for you, but might be something totally new. Now, there's a lot of different ways that you can, create these files. So, like you can use like some of the popular ones are Microsoft Office. There's also Google Docs, and there's something you may not know about called LaTeX, which that might be new to you. And you can use whatever you want. Now, that made it kind of difficult to figure out like how to have instructions on doing things because it'll be different in everything, whatever program you're using. I chose to use Google Docs because that should be available to everybody. And so you can use this and just follow the instructions, or you can use your own thing. And what I found, because I use something called LaTeX usually, or Open Office for simple documents. LaTeX is one of those great programs if you're going to be doing anything involving equations or like any scientific documents. The problem is it takes a lot to learn how to use it before you can really start doing much with it. But once you learn it, it's great. You can type up equations very easily. But yeah, I use Google Docs. And the thing is, I've never used Google Docs before typing up this and creating these instructions, but it wasn't that hard. So if you're used to doing it one way, like opening up something new and trying it, I think they're all basically similar. So it shouldn't be too difficult if you've done this before with one thing. If you want to switch to a different one, anyways, we can open up a Google document and yeah, it's kind of look at just the basic idea of typing equations. Some equations are very simple, like I mentioned here, Newton's second law, F equals ma. That's a very easy thing to type up. You can just use the keyboard. One thing though, equations, if you notice in books, are usually italicized. You italicize it instead of just writing F equals ma. But again, very standard stuff. Then you can look at here the quadratic equation, ax squared plus bx plus c equals 0. And again, you can do that with Office or Open Office fairly easily because you can use subscripts and superscripts. They've made that easy to do. But then if you write the solution to it, we've got this fraction that doesn't really fit on a line so well. Not everybody knows how to do that. And so his first assignment is going to be like learning how to type equations like this. And so that's going to be one of the main topics, typing equations in lab reports. Then we're going to look at tables. So like how can we make tables? And again, pretty standard stuff. But and then finally, images. Like, say we want to have this image in a document. How do we put it there? So fairly standard stuff, but might be new for some of you. And then we'll get to the actual assignment where it says open a new document, include your name in the top right corner, and then just type these equations. So that'll be problem 1. Just type these equations, and starting out with something fairly easy. Okay, and then like a square root. How do you type that? And here we have subscripts and superscripts. Here we have a trig function, which isn't quite as simple as just typing it with an exponent as well, fractions and so on. So basically, yeah, you'll put your name on it and then just type these, but you have to like use this actual math mode to do so. And then problem 2 is creating a table. And problem 3 is making a, let's see. Yeah, display the text below and the image in a 2-column format. So it'll kind of look like this. So that'll be your assignment. That's what you'll actually turn in. So you turn in, you kind of just start here. So everything before that is just instructions in case you don't know. Or you could watch the video. I'll do some of these things. So what I'm going to start with is open Google Docs and type this equation, the solution to the quadratic equation. So here's Google Docs. I'm just going to click blank, open it up, start with a name. Here. Okay. Whatever they said here. Okay. So again, I haven't done this in a while. I'm going to see if I can figure it out again. But we want to type the solution to the quadratic equation. So I'm going to hit insert and then scroll down to equations. All right. Let's start by typing. So x equals, and now we have a fraction. So if you look over here, math operations, you can see there's square root, parentheses, looks like subscripts and superscripts. Let's click that and see if we can find a fraction. Not seeing it. Let's see. I might have to look at the instructions myself. I haven't done this in a while. But I'll try to figure it out first. Okay, symbols, that'll come in handy later. Oh, I missed it. It was there all along. Okay. So we did x equals, and now we want a fraction, so let's click this. And right now we're like on above the bar. So we type minus b. And now we have this plus or minus symbol, which I saw earlier. I think it was here. Plus or minus. And now we have to put something under a square root. So I think this is our main one. Let's do square root. And then we have b squared minus 4ac. So before typing b, I'm going to see if let's do this. We want an exponent, so let's hit this and say b. I'm going to hit tab. I'm not sure if that's what to do, but yeah. Okay, so there's b squared, and then I'm going to hit the right arrow just to get out of the exponent. Let's see if this works. Okay, so that's all we want on the top, and then to get to the denominator, I'm going to hit tab and see if it goes there. Okay, I did it twice, but it went there. So yeah, let's see. And I'm going to exit equation mode and just see if this works. Okay, yeah, earlier I wasn't seeing the bar over that fraction, so I wasn't quite sure if it was going to work or not, but yeah, that worked out fine. It's kind of hard to see, so I'm going to make it bigger. Okay, so that was a reasonably complicated equation to type because you need a fraction, That not just like a number over another number, but like an expression over basically just a number. And it involves square roots and the special symbol, the plus or minus sign. I don't like how that square root looked exactly, but we'll go with it. Okay. Yeah, so interesting. You look over here. I wonder if you can just type this out and it'll create this, but yeah, that's fine. Okay, so we can type an equation like that. And we want it, and then in your assignment, problem 1 is going to be just typing several equations. So we'll start with first one is E equals MC squared. Wait, I think I'm in normal mode. So let's insert an equation. And let's just type E equals M. I'm going to try something and just see if it works. Oh, okay. So you can't see what I did, but okay. M, and then I did type C and then shift 6 for the caret, and it moved the exponent up. So I wasn't sure if it would do that or not, but it did. And there we go. E equals MC squared. Okay, so again, you can type all sorts of equations, and there's all these special symbols and relations. Yeah, you can just play around with it and find what you need. There's Greek letters here. These are often used. So that's something you might need later. But again, I didn't look at I kind of recommend not going through and reading all this. It's kind of detailed instructions. I recommend just playing around with it and then, resorting to instructions as a last resort. And if that doesn't work, you could always email me or something and ask. But overall, worked out well, except for this square root just looks a little, but that's fine. Okay, so that's equations. And then we have tables, where I'm going to make up a table. So again, insert. Let's see, where is table? Here it is. And you can kind of pick the dimensions, number of rows and columns. Let's make, let's say we have 4 columns and 6 rows. There's our table. And we can play around with this as well. This font is kind of huge, so I'm going to get back to something reasonable. I made it bigger to look at that equation. Okay. So here's a table. Now, very important, whenever you make a table, you should give it a name. Like here, let's say table 1, and then describe it. Like, what is this table? Description here. So it's important to give it a name. So like when you're writing your lab report, you can say like we put our data in table 1, and I can then see where that is. And probably come up with something to actually do with this, because we want to have like this first row should be a description of what it is. Probably made too many columns. Let's see what the assignment, or what did we do in the example? This was a simple one. So say we have a simple experiment where we want to measure the acceleration due to gravity. So we haven't talked about gravity yet, but say you drop something, it's going to fall to the ground, and it's going to be speeding up as it's falling. That's acceleration. And the acceleration, the kind of accepted value is 9.81 meters per second squared. And it's like, say we do an experiment to measure it, and we want to compare the results. So here I give it a name, table 1, and it's an acceleration due to gravity. Kind of a description of what this table is. And this one just has 3 columns and 1 row of data. So we have 1 row for description of what these columns are, and then 1 row for the data itself. And so, yeah, maybe I'll just recreate this. So one thing we could do is just delete that. let's make a new table. So insert table, we want 3 by 2. And so the first one is just description, where we have G. That's, oh yeah, we'll see G is the acceleration due to gravity. We're auto-correcting that. Okay, now G is a constant that has units, and the units are meters per second squared. It didn't work if so I tried, when you're in math mode, like if the document knows that you're typing an equation, if you hit the caret, it'll just automatically go to exponent. Here I want to do this. I want an exponent, so I've got to figure out how to get there. That's not it. Let's see. Not seeing the superscript and subscript. I wonder if I can use these. No, it won't let me do that. So, might have to refer to the instructions as well. What I use normally just has it next to like bold, italic, underlined, and then it just has the superscript and subscript keys, but this one does not. Wonder if we can. Seems to be showing everything we need. Okay. Oh, here, yeah, kind of unfortunate. There should just be a button for it that would make things easier. Well, if you go to Format Text Superscript, there we go. Okay, so there's G in meters per second squared. And I'm going to italicize the G. Now, we could do the same thing here. If you look in the document, then we had, this is just the standard value for G, the acceleration due to gravity. Here we have subscript, but it's kind of the same thing except for that subscript. So what I'm going to do is just take this and copy and paste it. Let's copy and paste. I have to control V for whatever reason. Now let's go over here. We want this to say G subscript N. So again, format text subscript, and then we can type NM. So copy and paste just to save a little time. And then what's next is percent difference. So that's a very important thing. Like here we have an accepted value for G. We do an experiment. This is what we get. And, we want to compare these two things. Like how close are we to the actual value? And so what we did is, the formula I gave is here. We take G minus GM. So we take on the numerator, that's just the difference in the two values. And we want to compare that to the value itself. Like just saying the difference is 0.72, is that big or small? You need something to compare it to. So in this case, we're going to compare it to the accepted value and then multiply by 100 to get a percent, to convert it to a percentage. And in this case, it turned out 7.3. So 7.3. We can just put these numbers. This is 9.81. I believe that was 9.09. Now, one more thing. I'm going to highlight all of this and center it. Figure out where that is. I think in normal text, it's, okay, align. See if that's still there. Okay, here we go. Click align and center. Okay, so we just recreated what was on the the assignment, the description of how to do this. So you can make tables like that. I made another example with more data. And the main reason I did this is something I see all the time in lab reports. Let me show you what I see in lab reports all the time. Go down. Something like this. You could say, like, make this a reasonable size again. Okay. Like, say, I'll just keep the same table. But, like, say there was a lot of text before that. And then so you're scrolling down. It's like, here's page 1, table 1, and then the table's on the next page. And it's really easy not to do that. In this case, all you do is hit enter and just move the whole thing down. So this happens a lot with images too, like figure 1 and then the figure's on the next page. So typically just move everything down, the description and the table. Now, if you have a long table, I'm going to see if I can expand this. I'm going to right click. Here we go. Insert row below. So I'll just insert a bunch of rows. Sometimes you might have a large table where if, it naturally occurred here, if you're just typing, but then some of it's on the next page, if you move the entire thing down to the next page, that can leave a lot of extra space here that might not look good. So there will be rare occasions, probably not in this class, where you actually want the table to go, split from one, have part of it on one page and then part on the next page. And again, if you're just scrolling through a document, it doesn't look like a big deal. But if you are looking at, if you were to type this up and have a table on 2 separate pages where you have to flip back and forth, and again, if you're looking here, if you have a lot of columns, you might not remember what they are. So if you ever have to split a table, you definitely want to do this. Copy that descriptive line. So at least if you, try not to do this, but if you have to, then do that. So copy the descriptive text so you don't have to flip back just to see what each column is. So again, that's just for future. If you ever have to do something like this, you want it to look nice and be easily readable. I don't think that'll be an issue here. Just move. We're not going to have anything so big that it has to cover 2 pages. If it's close, just kind of bump it down to the next page. Okay, so that's tables. And you could also put something above it and just say, like, table 1 continued. Wonder if I did that. Yeah, I did that here. So that might be a good idea as well. So you can see, like, what that actually is. Okay. So that's, also I talked about, like, if you want to shade a row or something, you can do that. And finally, inserting images. So here we have this image, which is on Canvas. So you can find it there. And this is something that will come up very frequently in lab reports, because a lot of times what you do on the compute, the computer will create an image. It'll basically like a scatter plot where you have data points, and it'll make like an XY plot with data points, and you can fit a line to it or something. And this is going to come up a lot, so we need to be able to take that image, which will be saved as a file, like a JPG or a PNG or something, and actually put it in your lab report. So one thing, very important, like here I labeled figure 2 and gave it a name, mass on a spring. And this figure is kind of small. So you don't want to, like, here, let's kind of do this again. We'll recreate this part. Now, if you go down to the assignment, it says go to Canvas and download the distance time plot. So that's the file that you're going to do is that you're going to insert is on Canvas. Actually, I have to double check that and make sure I've got the right plot. I'm going to do this mass on a spring thing. So let's do this. I'm going to recreate this. So what I'm going to do is I'm going to copy and paste this part of it. And why not save some time? Go back to Google Docs. It doesn't like copy and paste for whatever reason. Let's get back to a reasonable size. Okay. So let's say we type this up. And then we've got this equation, which actually I want to show you the equation. If you look at this, it looks like W equals a square root of K over M. We're going to learn later that's not a W, that's a Greek letter omega that looks just like a W. If you type W, I probably wouldn't, care too much. Certainly not enough to take points off, but let's insert this equation. So instead of typing W, the Greek letter omega, which we should be able to find here. Here it is. Okay, so omega equals, and then we have a square root. So let's click square root. And now we want a fraction under the square root, so a fraction. And it was just K, so I typed K and then tab and then F. And there's our equation. And then I put that stupid line above it. Doesn't do a good job with that, but yeah, that's fine. And I want to actually center this. Okay. And then let's look here. The period of the motion is given by this equation. So first I'm going to... Oh yeah, we can't copy and paste for whatever reason. It doesn't even object to copy and paste. It just doesn't want you to use the keys for it. They don't have any idea why they would insist on that. Now let's put this equation. So there was t equals, and then we had a fraction 1 over 2 pi. Not sure if I'm in... let's just start over. Insert equation. T equals... So we have a fraction 1 tab 2, and then, of course, Greek letter pi. And then I'm going to... Now, we want to stop... we want to get out of this fraction, so I'm going to hit the right arrow and see what happens. And then we have a square root. Let me try that again. Okay, so square root m over k. So I did m tab k and exit. Now again, these are kind of hard to read because it's small. So I'll leave the text the same, but just make the equations bigger. So at least make sure they're the same size as each other. Okay. So the period is given by that. So what we're doing is just trying to recreate this. Then we want to include the figure. So I'm going to insert an image, upload from the computer. So what I'm going to do is just, I've got it somewhere on here. Lab 1, mass on a spring. There it is, it's huge. So we're going to want to shrink this. Okay, so I was kind of testing it. Yeah, you can see you move around. It keeps the aspect ratio the same. So you can probably set it so that it will, you can adjust them independently. But if you adjust one, it automatically keeps the aspect ratio the same. I'll make it even a little smaller. And so what I'm doing is just typing this all as like a single column. And this doesn't look all that great because it's like we have this, this equation with that takes up the entire line, and it's not much of an equation. It's pretty small. And so this is in cases like this. If you have like a big picture, you can just put it there. But with a small picture like this, I can center it using this alignment tab. It's close enough. Okay. Sure, it's possible. But what I'm going to do is I'm going to select this entire section and see if I can get this in a 2-column format. Try format, columns, 2. Okay. So this just looks a lot better if you do it this way. So you have the descriptive text here, and then the picture, and the picture is not too big. I shrank it, and then it moved it down to the next. There we go. So you can do this in your lab reports as well. So you have the text and then the figure there, and it's just more compact, and it avoids having like this kind of small picture that takes up the entire width of the column. So if you want to do that, it just makes things look nicer. Okay. And I think that's it then. So we've got our 3 basic things. We have equations, tables, and figures. And yeah, I'll just get back here, and that's what we're going to do. Oh yeah, there's one more thing I want to point out. So yeah, problem 1, equations. Just type out these equations. And problem 2, I've had a lot of issues with this. I tried to clarify a little bit, but yeah, so here we have the period of a pendulum is measured 5 times, and the results are, here, 3.5, 3.7, and so on. The theoretical value is 3.4 seconds. Calculate the percent error and display the result in a table. And when I did that, so remember the percent error, we did that earlier. Here, we had this table with like our measured value, the theoretical value or the accepted value, and then the percent difference. But now we have 5 measurements. And so what everyone did is made a table with 5 rows of data and calculated the percent difference between each of these numbers and the theoretical value of 3.4 seconds. But that's not what I was looking for, so I tried to clarify that. You should have 3, should consist of 3 numbers. Your theoretical value, experimental value, and percent error. So it should look just like this table with, your theoretical value here, the first column, your measured value or experimental value and percent difference, and there should just be 1 row of data. So what you're doing in an experiment like this, you want to measure the period of a pendulum. That's how long it takes to swing back and forth. And you measure with a stopwatch, and the problem with doing that is there's going to be errors in the measurement. Maybe you hit the stopwatch too early, maybe you hit it too late. And so to improve the experiment, what you do is you redo the experiment several times, and then you take an average. So what you're going to do for this problem is you're going to average these values. And that'll be the experimental value. So you have 1 experimental value for the period, which will be the average of these numbers. And then you compare that to 3.4 seconds and find the percent difference. So yeah, your table will look just like this with, period instead of G. You'll have like T in seconds, and you'll have like T theoretical, T experimental, and percent difference. And then the third one is kind of like this part here, where what you do is you literally copy and paste this, except you type up your equation. You could probably just copy and paste the whole thing and then delete the equation and type it up. Yeah, let's see what happens if we just copy and paste this. Try to remember to Control V because they're so weird about that. Yeah, you see the equation just doesn't work at all. And so then you can just delete that. leave that space, and yeah, then put that equation in there. And then what I would recommend, just do it like this, and then put the image, which is on Canvas, put that underneath, and then highlight the whole thing, and make 2 columns out of it. So again, there's 3 main topics. So there's 3 questions to do for this assignment: equations, tables, and images. And that's it. So yeah, I recommend just opening up your program of your choice, either Google Docs or Office or whatever Mac uses, and just play around with it. If any of this is new, just play around with it. Another great thing you can do is you have like a particular, like, how do I do this? You can literally type your exact question in YouTube and someone probably answered it. So yeah, a lot of trial and error. Just play around with it. Should be able to figure it out without too much difficulty. And again, any questions, can't figure it out, you can always ask, email, or uh, ask during like a Zoom class. Okay, so we'll stop here, and that's it for this first